Okay, good morning to all of you. So today we'll start the CAD-CAM-C lecture number 7. So before starting the lecture, I will take the attendance. So give me the attendance. Roll number 1,
Present, sir.
roll number 2,
Present, sir.
roll number 3,
Yes, sir.
roll number 4,
Present, sir.
roll number 5, roll number 6,
Yes, sir.
roll number 7, roll number 8, roll
Yes, sir.
number 9.
Nine, yes,
Survey
sir.
roll number.
8.
Survey roll number किती? 8.
हाँ.
ठीक है. Roll number 9,
Yes, sir.
10,
Yes,
10,
sir.
11,
Yes, sir.
12,
Yes, sir.
भोसले 13,
Yes, sir.
भोसले ठीक है. 14 देशमुख, 15 धोत्रे, 16,
Yes, sir.
17,
Yes, sir.
18,
Yes, sir. Sir,
19. Okay,
Hello.
14 present. 19. हाँ 14 present. 19. वाघमोड़े 20, 21.
21
कदम,
present. Present, sir.
22. Yes,
Yes, sir.
22.
Yes, sir.
23. Yes, sir. 24. 25. 26. 27. 28. 29. 30. 31.
Present.
32. 33.
Present, sir.
34. 35.
Present, sir.
36. 37.
Yes, sir.
38. 39.
Yes, sir.
40. 41.
Present, sir.
42. 43. 44.
Yes, sir.
45. 46.
Present, sir.
47.
Yes, sir.
48.
Yes, sir.
49.
Yes, sir.
50.
Yes, sir.
51. 52.
Yes, sir.
53. 54.
Yes, sir.
55.
Yes, sir.
56. 56. 56. 57. 58. 59. 60. 61. 62. 63. 64. 65. 66. 67. 68. 69.
Yes, sir.
70.
Yes, sir.
69. Okay.
Yes, sir.
Yes, okay.
Sir, 20.
20. Okay.
Sir, 5.
Okay. 5. Okay, Vinayak Gauri present, Sumit Patwari present, Shubham Devkar present. Okay, so we'll start our today's lecture. So in previous lecture we have seen the problem on the geometric transformation. So I think everything is clear about the geometric transformation problems in that simple and in that homogeneous transformation problem. So can we move forward for next point, that is geometric modeling, or whether you want more problems on the geometric transformation? Anyone? आपण पुढचा पॉइंट घेऊया का आपण प्रॉब्लेम बघायचे अजून? कोणाला अडचण असेल, कोणाला अजून प्रॉब्लेम समजले नसतील, कोणाला अजून रिपीट प्रॉब्लेम बघायचे असतील, नसेल तर पुढचा पॉइंट घेऊ शकतो का? हा, तुम्हाला जर काही डाऊट असेल तर चॅट बॉक्स मध्ये टाइप करा. एखादी गोष्ट कळली नाही, एखादी गोष्ट रिपीट करायची किंवा प्रॉब्लेम समजले नाही सर रिपीट सांगा, असं काय आहे का? अदरवाइज then we will move towards the next point, our second part of this second chapter. हा, कोणी? धोंडीराम, रोल नंबर 20.
हा सर.
हा, प्रॉब्लेम समजलेत का? हा, प्रॉब्लेम समजलेत का म्हणलं जिओमेट्रिकचे का सांगावं लागते अजून परत? आवाज कट होतोय धोंडीराम, आवाज क्लिअर येत नाही तुमचा. हॅलो अभिजित खोटे.
हॅलो सर.
हा धोंडीराम, आवाज येतोय का?
हा येतो सर.
हा, म्हणलं पुढचा पॉइंट घ्यायचा का प्रॉब्लेम सांगू परत?
घ्या सर.
घ्या सर पुढचा पण.
बर बर, ठीक आहे ठीक आहे. सो वी विल मूव टुवर्ड्स आवर नेक्स्ट पॉइंट. Okay, visible?
Yes sir.
Yes, sir.
Okay. So already we have covered the first part of the second chapter, that is the geometric transformation. In that we have seen that the simple problem on the translation, rotation, mirror, scale. So already we have covered the second important part, that is the homogeneous geometric transformation. And basically in university examination they will ask one definite fixed question on this point for 7 marks. So we have already covered the homogeneous coordinate transformation, a theory part as well as a problematic part. So we have seen a simple problem as well as a homogeneous problem also. So if anyone is having any doubt regarding this problem, you can ask me anytime. You can call me, you can message me on the WhatsApp, so I will clear your doubts. Okay. Then we have seen windowing, viewing function, coordinate, then standardization. What are the functions of the graphic system? Then various graphic standard for this graphic system, GKS, PHIGS, IGS. Then last is data exchange with direct form and indirect form. So we will see next part. So that is our main second part of this chapter, that is a introduction to the geometric modeling. Okay. So what is mean by geometric modeling? Might be everyone knows about the modeling. Okay. I think in second year you have learned the CATIA software. Okay. So everyone knows the meaning of the modeling. Okay. Modeling, in that we are going to create one of the product part, like the prototype. So in that in earlier CAD system, means far before in our this era, in earlier CAD system were basically means automated drafting system which displayed a two-dimensional representation of the object being designed by using such a system, the drafting process could be accomplished in less time process, and the productivity of the designer could be improved. Okay, so whatever our coming new CAD systems, by using this CAD system we are going to design a prototype model, and in that model we are going to create drafting part. We are going to achieve different parameters within a less time by using this latest CAD system. Okay, but in previous whatever that old method for the designing any product, they are using the old CAD system. Here they are using drafter, pencil, whatever that instrument is there, and that instrument will take for the long time for the designing any product, and it is quite difficult to find out the all details of the that model. Okay, as compared to our new CAD system. Okay, in that however there was a fundamental shortcoming in this early system. Though they were efficient and of the high quality, the object drawing were stored in a two-dimensional, and whereas a physical object in the three-dimensional form. So in early CAD system was unable to cover the three-dimensional part, and this coming all recent CAD system, we are eliminated that problem, and we are developing a capability to store the three-dimensional data. Okay, and one of the most popular and effective use of the complex in the representation of the physical system, the general term used for this type of the application is modeling. Okay, so basically I am trying to say like this: in a modeling part in previous CAD system there is no such a system to design a three-dimensional part. Okay, so but in this new CAD system, by using various software, we are easily from a three-dimensional modeling a prototype a model. Okay, that is the use of our new CAD/CAM CA software systems. Okay, so basically modeling, the geometric modeling, it is a process of the capturing properties of an object or a system using some mathematical formulas. Okay, whatever we are creating a prototype on the model on the any software, suppose we are taking the example of the CATIA software, so beyond that screen they are creating a script, and behind that they are creating some matrix formula in the mathematical ways, and they are capturing all the information regarding that the product. All information means like that whatever input data of that model means dimensions, material properties, boundary condition, material condition, whatever that we are going to apply on that particular model, whatever that all the data is stored in that mathematical steps. Okay, so that is called as a geometric modeling. In computer modeling, it is a field that discusses the mathematical methods behind the modeling of the realistic objects for the computer graphics and computer aided design. Whatever we are going to create any model on the computer system by using various CAD systems in 3D format, it looks like a real product. Okay, but it is actually by using computer graphics and CAD design, we are going to develop such a product which is visible actually in a realistic object. That is the beauty of our new CAD system. Okay, so by using this new system, we are going to create a realistic object. So that is the main motto of our geometric modeling. So in that point, we will see a different type of the geometric modeling and their advantages and disadvantages. So we'll start from the first, that is a wireframe modeling. Okay, wireframe modeling is nothing but it is a simple just wire. Its name indicates like wire. It is structured like only wire. It has no surface. It has no solid part. Okay, so it is just a process of the visualization of the three-dimensional part in the by using the 3D computer graphics. Okay, actually we are not going to show any surface. We are going to show any volumetric surface area in this modeling. We are going to see view all the skeleton and edge representation of the real world 3D object. Okay, using the different elements, points, nodes and curves. Okay, so this is the basic type of the modeling. Here we are going to just showing the skeleton representation. So this is the first type of the modeling, that is a wireframe modeling. Here we are just introducing the vertices which is having some coordinate and edges like that we are called as a element. So two vertices form a single element. So like this we are going to form different vertices, and by using these vertices we are going to create elements, that is the edges. So we are going to just show how product will look like this in skeleton format. Okay. So we'll see what are the advantages of this wireframe modeling as compared to other solid and surface modeling. So it is a quite simple method and requires less memory space. If you have created one wireframe model of the one car, okay, you can take this example of the car, four-wheeler car. So that is the simplest method to show the just structure of the car, and it will require a less memory to store in our CAD system. Okay. तुम्ही असं जे कोणते कोणते मॉडेल तयार करता तर प्रत्येक वेळेस त्या मॉडेलचं जे काही डेटा आहे इन टर्म्स ऑफ द मटेरियल प्रॉपर्टीज, त्याच्या सगळ्या बाउंड्री कंडिशन, लोडिंग कंडिशन, त्या सगळ्याचं मटेरियल एका कॅड सिस्टीम मध्ये स्टोअर होतं. ज्या तुम्ही सिस्टीम मध्ये ड्रॉइंग काढता त्याच्या पाठीमागे त्याचा डेटा स्टोअर होत असतो. मग अशा वेळेस वायरफ्रेम मॉडेलिंगला तो डेटा कमी लागतो, म्हणजे स्पेस स्टोरेज डेटा कमी लागतो, कारण की त्याच्यामध्ये आपण सरफेस आणि सॉलिड पार्ट हा रिमूव्ह केलेला असतो, फक्त वायरफ्रेम असतं त्याच्यामुळे त्याची मेमरी कमी असते. ओके, हा एक ॲडव्हान्टेजेस आहे. नेक्स्ट, इट फॉर्म्स अ बेसिक फ्रॉम सरफेस अँड सॉलिड मॉडेलिंग. ओके, इट इज अ बेसिक फाउंडेशन फॉर एनी क्रिएटिंग अ सॉलिड पार्ट और सरफेस. ओके, जर कोणतंही तुम्हाला एखादं 3D मॉडेल ड्रॉ करायचं असेल सॉफ्टवेअरवरती तर तुम्हाला सुरुवातीला वायरफ्रेम मॉडेल ॲज अ फाउंडेशन म्हणून हेल्प करतो. ओके, सो दॅट विल बेटर फॉर द क्रिएटिंग द नेक्स्ट पार्ट, दॅट इज अ सरफेस मॉडेलिंग अँड सॉलिड मॉडेलिंग. सपोज तुम्ही जर सर वायरफ्रेम मॉडेल क्रिएट केले कारसाठी आणि तुम्हाला ऍक्च्युअल 3D मध्ये प्रोटोटाइप मध्ये कार हवे तर तुम्ही त्याला फक्त सरफेसेस आणि सॉलिड पार्ट क्रिएट करू शकता नंतर विदिन अ लेस टाइम. ओके, बाय युजिंग दिस वायरफ्रेम मॉडेल यू कॅन इझिली क्रिएट अ surface and solid modeling of that car particular prototype. Okay, so that is also advantages. Next, manipulation in the model can be done easily and quickly. Suppose तुम्हाला जर काही changes करायचे असतील, once you created the wireframe and then you thought this line is not correct, this structure is something is going to wrong, so then I want to change that wireframe model, then you can easily change within less time and easily by using the changing the vertices and by changing the edges. Okay, so that will be easy for the changing the design and structure of that wireframe model. Okay, so that are the main advantages of the wireframe model. So next we will take next point, that is a disadvantages of the wireframe models. आता याचे तोटे काय आहेत की wireframe मॉडेलचे, तर काय आहे, one of the serious limitation is the ambiguity of the orientation and viewing plane. ओके, सो सगळ्यात मोठा म्हणजे ह्याचा तोटा काय आहे तर आपण वायरफ्रेम मधून ना की कोणत्या बाजूनी कोणत्या प्लेन मधनं आणि कुठल्या ओरिएंटेशन बघतो हे समजणं खूप अवघड जातं, कारण की सगळीकडे एजेस आणि पॉइंटच दिसतात. ठीक आहे, एखादा सॉलिड पार्ट असेल ज्याला सरफेसेस आहेत त्याला आपण सांगू शकतो की मी राईट हँड साईडने बघतोय किंवा लेफ्ट हँड साईडने बघतोय किंवा मला ओरिएंटेशन ॲज अ टॉप व्ह्यू ठेवायचं आणि मला ड्रॉइंग या साईडला करायचंय. तसं वायरफ्रेम मध्ये इट इज अ क्वाईट डिफिकल्ट टू आयडेंटिफाय द व्ह्यूइंग प्लेन अँड ओरिएंटेशन फॉर द drawing. So this is a major drawback of this wireframe model, and due to this it is very difficult to interpret the object from particular viewing plane and creates confusions. Okay, so याच्यामध्ये खूप कन्फ्युजन होते की मला कुठल्या साईडला प्लेन वरती ड्रॉइंग करायचंय आणि कोणत्या साईडला ओरिएंटेशन ठेवायचंय. सो इट इज क्वाईट डिफिकल्ट. सो दिस इज अ मेजर डिसएडवांटेजेस. Then second, lack of the information to determine objects profile such as a circles and curved surfaces. मीन्स एखाद्या सॉलिड पार्ट आणि सरफेस पार्टला आपण ऑलरेडी ड्रॉइंग करताना त्याला मटेरियल प्रॉपर्टीज दिलेल्या असतात, त्याच्यामुळे मी इझिली एखाद्या सरफेसला फिलेट किंवा चांफर किंवा मी सरफेस फिनिशिंग मला जेवढी हवी तेवढी मी by using CAD tools we are going to create easily. But in the wireframe model it is quite difficult to identify profile. Here I want to create the surface and curved surfaces and any other activities or any other curves on that surfaces. Okay, because there is no surfaces, just we have to identify the particular that edges and then we have to create that lines. So it is quite difficult. So this is a second major disadvantages of this wireframe model. Third, that is the physical properties such as mass, surface area, volume, center of gravity. It is not possible to calculate. Obvious आहे की याला आपण फक्त वायरफ्रेम मॉडेल बोलतोय म्हणजे त्याला सर्फेसेस नाही येते, सॉलिड पार्ट नाही म्हणजे त्याला मास नसणार आहे, एरिया कॅल्क्युलेट करू शकत नाही, व्हॉल्यूम अँड सेंटर ऑफ ग्रॅव्हिटी. सो दॅट इज अ not possible things to calculate the such a properties, okay, in the physical terms. So that is also major drawback. So, fourth one, that is the wireframe model has no knowledge of the surface faces. Therefore, it will not detect interference between two mating components. At the time of the assembly or at the time of the drawing, we have to choose surfaces to surface contact for the assembly purpose or any joining purposes. So in wireframe model, there is no knowledge about that surface faces because there is no surfaces. So that will be create the major problem at a mating components or assembly time. So this is a serious drawback, especially in a component assembly, kinematic analysis, NC tool and robot arm simulation. So that is also major disadvantages. Next, fifth one, to construct model we require lot of data compared to solid model. So आता आपण अशा ठिकाणी आहे की सुरुवातीला मी म्हटलो की वायरफ्रेम मॉडेल हे सगळ्यात इझी मॉडेल आहे ॲज कम्पेअर टू सॉलिड अँड सरफेस. ओके, करेक्ट. आता मी काय म्हणतोय की जर सॉलिड वायरफ्रेम मॉडेल कन्स्ट्रक्ट करायचं असेल तर याला खूप डेटा लागतो ॲज कम्पेअर टू सॉलिड मॉडेल. तर आता कसं आहे, ज्यावेळेस वायरफ्रेम मॉडेल एखाद्या गोष्टीचं मला क्रिएट करायचं आहे त्याच्यावेळेस मला त्या प्रत्येक पॉईंटची प्रत्येक लाईनची मला वर्टायसेस प्लस त्या एजेस आणि एलिमेंटची इन्फॉर्मेशन हवी होती. ठीक आहे. तसं सॉलिड मॉडेलमध्ये कसं आहे, डायरेक्ट मला सरफेसची इन्फॉर्मेशन आहे, मी डायरेक्ट मोजके 3-4 सरफेस जोडले की त्या सरफेस जोडल्यामुळे मला n नंबर ऑफ पॉईंट्स आणि n नंबर ऑफ एजेस ऑटोमॅटिकली क्रिएट होतात. ठीक आहे. सो दॅट विल बी ऑल्सो मेजर डिसएडवांटेजेस इन वायरफ्रेम ड्रॉइंग मॉडेलिंग. We have to put the information regarding all the points and all the lines, so that will be quite difficult to construct a model. Means it requires large data as compared to solid and surface model. Okay, so wireframe both in geometric and topological. Topological means shape of that model. Okay, so geometrical means whatever the dimensional value and shape are needed, while solid requires only geometrical. Okay, so this is a difference in between the during the construct the model in terms of the wireframe and solid. So next, do not represent an actual solid. So obviously there is no surface, no solid part, so there will be not representing the actual part. Wireframe is only for the representation of the construction of that model. Okay. So last point is cannot model complex curved surfaces. So by using this type of the modeling, wireframe modeling, we are unable to create a complex part surfaces or geometry. Okay, so this is also, so these are the some major disadvantages of the wireframe model. So we will see what is actually a wireframe model. Okay, we will take the just small recap of this first type of the modeling. It is one of the part of the geometric modeling. So wireframe modeling is actually representation of the three-dimensional physical part used in computer graphics, and it is actually only representing the skeleton part of that particular object. Okay, so that is called like the wireframe modeling. So it is the simplest method and it requires less data. It forms a basic part for the surface and solid modeling. It can be suppose I want to do some modification or manipulation, so it will be easy and quickly. So that are the advantages of the wireframe model. There are some disadvantages we can call as just drawbacks. So we cannot select or we cannot set orientation as a point of view for the next drawing. So that will be a limitation in this wireframe. Then so information regarding that the surfaces, so I want to create some curves, I want to create some entities at the node, at the surfaces, at the corner, so that will be critical task in this wireframe. So it is unable to calculate the mass, suppose unable to calculate just physical quantities in terms of the wireframe, and there is no surfaces, so at the time of the assembly it will be create some problems. And as compared to solid and surface, so wireframe is required a lot of data to create the construction model, and it is not actually a solid part, and it is a complex to the draw this wireframe. So this is about wireframe modeling, the first type of the geometric modeling. If anyone is having any doubt, any question regarding the wireframe modeling, then you can ask me here, or otherwise you can just put your question in the chat box. Hello, yeah sir, or anyone else? Aniket?
Yes, sir.
No, sir.
हा, एनी प्रॉब्लेम? असं काय आहे का समजलं नाही किंवा डबल सांगावं लागेल?
नाही सर.
हॅलो, ठीक आहे ना, समजतंय ना, स्पीड वगैरे फास्ट होत नाही ना?
नाही नाही. ओके.
ओके ना, ठीक आहे.
Yes, sir.
आपण नेक्स्ट पॉइंटला जाऊया. नेक्स्ट मॉडेलिंग टाइप ऑफ द geometric is a surface modeling. Name itself indicate as a surface modeling, so we are going to create a surface. So in a surface modeling, objects are defined by their boundary faces. Okay, so bounding faces means we are going to joining the vertices with edges and surfaces, so it will create a new surface. So that will be created in this surface modeling. So surface model is a set of faces. We are going to joining the different faces with a different edges and vertices. So that will be create one of the entity. A surface model consists of wireframe entities that form to the basic create the surface entity. In previous modeling, we have seen that we are going to create only wireframe model. Okay, and by using that wireframe model, we are going to joining only particular that face by using this vertices, and that will be created our surface. Okay, so at the time of the surface modeling, we are going to using the previous wireframe model. So that will be act as our basis, means our foundation for creating any surfaces. So wireframe model is also important for drawing any surface modeling. Okay, and a surface model consists of wireframe entities that form the basis to create surface entities. In general, a wireframe model can be extracted from a surface model by deleting or blanking all surface entities. सपोज आपण एखादं सरफेस मॉडेल क्रिएट केलं आणि मला नंतर वाटलं की मला याचा वायरफ्रेम बनवायचा आहे, ठीक आहे, तर आपण डायरेक्टली इझिली जे काही सरफेसेस आहेत ते डिलीट करून टाका, सबस्ट्रॅक्ट करून टाका, तुम्हाला ऑटोमॅटिकली परत वायरफ्रेम मॉडेल भेटेल त्या मॉडेलचं. ठीक आहे, सो दॅट इज ऑल्सो बेनिफिट इन दिस सरफेस मॉडेलिंग. After getting the surface modeling, if you want to create again wireframe model, you can simply delete or subtract that surface from that entity, then you will get the wireframe modeling. Okay, so that are some features of the surface model. Then there are some typical surfaces in this surface modeling, like plane surface means only plane surface. Then ruler surface means there is like shape like waves. Okay, so I will just show you. Okay, so first type of the surfaces is a plane surface. Plane surface means just only like this. Okay, this is your plane surface. I am going to divide this with a net-like structure. Okay, this is our plane structure. Means this is the simplest surface. It requires 3 non-convenient points to define an infinite plane. Okay, so here you require just the 3 non-convenient points. Here you define the infinite plane. Okay, so this is the first type, that is only plane surface. Next, second surface is ruled surface. Ruled surface. Ruled surface means this is a linear surface. it interpolates linearly between a two boundary curve and that define the surface, and surface can be any wireframe entity, and this entity is ideal to represent surface that do not have any twist or kinks. Okay, so ruler means suppose I have this one line and I have this second line. So I want to create a surface with ruler profile, means previous is a straight, okay, plane means there is only plane surfaces, but I want to create any ruler means we can call as lofted. We can call as lofted. So like this, I am creating the ruler surface. So like this, we can create any ruled surface or lofted surface. You can give as an name as ruled or lofted. So like these surfaces, this is called as ruled and lofted. So third one, that is a surface of revolution. Okay, surface of revolution. So surface of revolution means might be you have studied in CATIA software. Suppose I want to create one entity and by using axis. So you just we have to just draw one axis, and along that axis you have to just symmetrical part you have to draw, and then you can just revolve about this axis. Then you will get the whole geometry by using this command. Like this is called as the surface of revolution. Like this, I want to create one entity. So before that, I want to just create one axis, and around this axis, I am going to create one of the drawing. So this is a planar curve. So by using this entity, I am going to create one model. So just we are using the sweep command and in CATIA. So in that time, we have to select the axis symmetric surface around that axis. So it will be revolve about that axis, and it will be created some geometry. So this is the about the surface of the revolution. Next surface, that is the surface number 4, that is called as a tabular cylinder surface. Tabular cylinder surface. Okay. So this is a surface generated by transiting a planar curve a certain distance, drag a specified direction. Okay. It is a simple type of the surface where suppose I will take this circle, okay, and I want to create a cylinder circular part from this circle. So you can use tabular cylinder surface. You can extract, we can extend that circular part with the help of this command, and you can create a cylinder. Okay, so from this circle I am going to create one tabular cylinder like this. Okay, so this is the part of the tabulator cylinder surface. Next, like this, suppose this is one line and I want to create one tabulated. So you can just create surface like this. Okay, so this is the example of the fourth type of the surfaces, that is a tabulated cylinder surfaces. Then next, fifth, that is called as Bezier surface. Bezier surface. Okay, so this is the surface that approximate given input data. Okay, तर असे हे सर्फेस आहेत की त्याच्यामध्ये आपल्याला कंप्लीट 100% डेटा माहित नसतो, त्यावेळेस आपण हा कर्व यूज करतो. ठीक आहे. इट इज अ डिफरंट फ्रॉम प्रिव्हियस सर्फेसेस इन दॅट इट इज अ सिंथेटिक सर्फेसेस. Okay, similarly to Bezier curves, it does not pass through all given points, and it a general surface that permits twists and kinks links. The Bezier surface allows only global control of the surfaces. Okay, so just I will show you one example of the Bezier surface. Suppose I have a 10-point coordinator data, and I am drawing like this. This is my point 1, this is my point 2, this is point 3. Like this, I have some points, and in Bezier surfaces, I don't know all the data of that particular part. So, and I want to create our surfaces by using Bezier. So basically Bezier surfaces is not passing through all the curves. Okay, so like this we have to create the surfaces. Okay, so this is known as a Bezier surfaces, and at the last point of this chapter we will see and the details, types of the curves, what are the advantages, what are the disadvantages, and what are the properties of the curves. Okay, so basically a Bezier surface is nothing but we are going to draw the surfaces. Here we are having not 100% information about that part, then we are going to create the surface. Okay, so next surfaces is B-spline surfaces. 6 number, B-spline surface. So this is the surface that can approximate of the interpolate given point data. It is an symmetrical surface. It is a general surface like a Bezier surface, but with the primitive local control of the surfaces. Okay, so in previous surfaces, that is the Bezier surfaces, there is no local control, only the global control is there. But in this B-spline surfaces, the permitting local control is. Okay, so local control and global means I will show the example. So suppose these are the some points, and this is the curve passing through these points. Okay, that is called the B-spline surfaces, and they are passing through the surfaces like this. Okay, so this is the B-spline curve. Suppose I want to create the nature of the curve for this first B-spline surfaces. Okay, suppose this is your previous B-spline curve, and I want to change. Okay, like this, I will take at the same point. I want to change this point at this location. Okay, I will drag this curve in upper side. Okay, by using local control. So this point is called as a control point. Okay, this point is called as a control point P1, P2, P3, P4, and P5. So generally we call it as a local control point. So in this B-spline surfaces, we can easily control the local points. With the help of that local point, we can create or change the nature of the curve. Okay, and then I want to change the nature of that curve at a point 3. So look, I will create a curve with new point. So this is your P1, P2, P3, P4, and P5. So I want to change our curve nature at the point P3 by using local control point P3. Okay, so that will be permitted in the B-spline surfaces, but in the previous Bezier curve, that is not permitted. Okay, so this is the difference between the Bezier surfaces and B-spline surfaces. Okay, so this is the type of the surface modeling. So surface modeling, we will go for our PPT. Okay, so we have seen that the types of the surface modeling. So what are the advantages of the surface model? So basically in that surface models eliminated much ambiguity and non-uniqueness present in wireframe model by hiding the line not seen. Okay, so whatever the drawbacks in wireframe model, whatever the ambiguity, what are the difficulties in a wireframe model, we are going to delete or eliminate in the surface models. Okay, so in renders the model for better visualization. Render, it is one of the tool for the improvising the surface finishing or visualization in the modeling. And presentation objects appear more realistic. So by using as a foundation wireframe model, we are going to create a surfaces. So for that better visualization, we are going to create some rendering surface finishing on that surfaces. So that presentation, that object looks like a realistic product in terms of the surface modeling. So provides the surface geometry for computer aided manufacturing. So in the CAM we are going to create an actual product, so they are providing a surface geometry for CAM as a manufacturing purposes. NC, that is a numerical control machines for further production. So it is a quite a good point related to direct production. So there is no any other CAD system procedure for that particular part. So for further manufacturing. So okay. So in that surface modeling, we will get first we are going to eliminate the what are the drawbacks in wireframe. That is the most advantages. By using surface modeling rendering, we are going to show better visualization of that product object. Okay, and that will looks like a realistic, and it is quite easy to give that surface geometry direct the CAM and the NC machines for the next process. Okay, so that are the advantages of the surface modeling part. Then it provides the geometry needed by the manufacturer engineer for mold and die design. Okay, so whatever that design engineer need or manufacturing engineer need for the further production, so it will be needed for making the die design mold for that particular product. Okay, so that is also a benefit. It can be used to design and analyze complex free-formed surfaces of ship hulls, airplane, fuselage, and car bodies. Okay, whatever that complex geometry present in the airplane, fuselages, car bodies, ship. So that complex designs and analysis that will be created and that will be analyzed in the surface modeling by using various surfaces. Already we have seen different types of the surfaces like plane surfaces, ruler surfaces, tabulated. Okay, then Bezier, B-spline. Okay, that different surfaces we are going to using at the complex geometry. So that will be easier to the create the different part. So that is also benefit. Surface properties such as roughness, color, reflectivity can be signed and demonstrated. Okay, so surface is having a lot of properties in that. First of all is roughness, means we are going to present that surface of the particular part with which level. Okay, that is a grade is there. We have studied in already in machine drawing. Okay, so there is a color is there, the reflectivity there are, means lot of property to show that surface like different parameters. So that will be also demonstrated. Okay, by using this surface. Then there are some disadvantages regarding the surface modeling. So it provides no information about the inside of the object. Okay, so in previous wireframe model we have seen there is no physical data. Okay, in terms of the area, mass, volume, in terms of the any properties information, they are not going to store because there is only construction model. But in the surface modeling, we are going to create a surface by vertices and in edges. But at the inside of the part, there is no object. Okay, so there is no information regarding that the particular part. It will not provide. By using this surface model, we are going to create only surfaces, and inside of these surfaces there is no information about that particular model. Okay, so that is a drawback. So for the curved surfaces, need a fine mesh to be accurate. Whatever that curve structure is there, complex geometry is there. So for that particularly, fine mesh is required to accuracy for better result. Okay, so if we are going to create a coarse mesh means mesh quality is poor, and we are going to create a fine mesh. So by default for fine mesh, for computer system requires a large memory, and time also, computational time is also required too much. Okay, and for it will require the more time, and it indicates direct the lower productivity of the company. Okay, so it is quite difficult to create a curve surfaces, and for that we have to need a make a spine mesh. Okay, so customer as per customer needs and feedback, we have to create the particular part design. Then for better design and better accuracy and our aesthetic look, we are going to create a fine mesh surface finishing, so that will require the a large time and huge money, and that will be creates some problems in for the company. So we have to do the optimization techniques for that particular points, and then we will optimize the cost with respect to that particular aesthetic design. Then we will get the optimum design, and then we will make a profit in that particular model. Okay, then it provides a wrong result if mesh is a two course. If we are going to create with a course fine, then that will be sufficient as a product, but it will be give a wrong result for the next further processes or analysis in a FEA software. Okay, so it is complicated computation depending on the number of the surfaces. If a geometry is a complex, then definitely it will create a problem at the time of the computation. If your mesh is a fine, means we are going to create a fine mesh, it will be take a large computational time, but it will provide a greater accuracy for your product. But you are going to create a coarse mesh, means it will be complete within less time. Okay, your computation time is less. Okay, but it will be give a wrong, maybe not accurate results. Okay, so that will be create a further problem for the further NC programming. So suggestion from the company software provider, they will just say like that you can create the fine mesh. Okay, so for the further accuracy. So that is the some disadvantages of the surface models. So next, whatever that we have already seen, the different surfaces is there. Like we have seen plane surfaces, ruler surfaces, sphere, cone, tabulated, bezier, B-spline, Gordon, nubs. Okay, so these are the some types of the surfaces. Here, analytical surfaces and synthetic surfaces. So whatever that bezier surfaces, B-spline, nubs, that is a category into the synthetic curves. So we will see in the details of the curves the last point of this chapter. This is only introduction part of the surfaces. Here we are going to using the different types of the surfaces. Whatever that complex geometry is there, for that purpose we are going to use this curve for the better product. So we can easily construct a complex geometry by using these synthetic surfaces and analytical surface. Okay, so this is the point of the kind of the surface. Now you can see already I have seen show you the plane surfaces, ruled surfaces, then surface of the revolution, how we are going to create one of the geometry by using the axis. About that axis we are going to create the symmetrical part of that geometry, and then we are going to revolve about that axis, and then we will get a geometry. Okay, then Bezier curve, cone surfaces, lofted surfaces. Okay, so if any doubt is there regarding the surface modeling, then you can ask me. If you are not understand what is the surface modeling. Okay, so previously we have seen the wireframe modeling. Now we have seen the surface modeling. So according to wireframe modeling, we are unable to store the physical data in terms of the mass, volume, area. Okay, so in surface modeling we are going to eliminate that the previous drawback of the wireframe model. Then we have created the surfaces by using the vertices and the edges in the surface modeling. Okay, but in this surface modeling, one major disadvantage is like this: inside of that surfaces there is no any information regarding that particular object. Okay, so that is the major disadvantages of the surface modeling. But one good advantages of the surface modeling is we can create any complex part of the geometry by using the analytical and synthetic curve. Okay, so that will be represented that entity. Okay, and you can using rendering tools, you can create a physical visualization for that particular part, and we will get a better visualization, like a aesthetic look and ergonomics looks. Okay, so customer will buy that our product. Okay, so that is the advantages and disadvantages of the surface modeling. We have seen the types of the surfaces. Okay, plane, ruled, sphere. For that particular condition, we have to use these different analytical surfaces as well as synthetic surfaces. Okay, if our geometry is complex, then we are going to using synthetic surfaces. Okay, so like this, we have seen that the surface modeling. So next part of the this geometric modeling is solid modeling. So we have seen wireframe modeling, then surface modeling, and last one is the solid modeling. So first of all, we are going to create a wireframe modeling. By using this wireframe modeling, easily we can form a surface by using different vertices. And last one, solid model. By using different surfaces, we are going to create a whole solid part of that particular model. Okay, so solid model is nothing but a solid definition includes the eliminate all the kinds of the ambiguity, whatever we have faced difficulties or drawbacks in wireframe model and surface model. That difficulties, ambiguity, we are going to eliminate in this solid model. In representing the objects, the solid modeler was developed. Out of the various approaches developed, one of them was an approach to design of mechanical parts by treating them as a combination of simple building blocks like cylindrical, cubes, cones. Okay, so what are the drawbacks we are facing in wireframe surfaces that are eliminating in this solid modeling? We are going to create a simple solid by using a combination of the blocks like cylindrical and you might be remembering in that CAD software and CATIA software there is one primitives like option is there, toolbar. In that primitives we can just select any primitives and you can create any entities like cylindrical, circle, pyramid, cone. Like this there is a ready-made geometry entity is there. Just we have to select them and place on the screen. Then that will be created the geometry. Like this, you can a combination of the different entities, primitives. You can create the a solid part, and the completeness of the information contained in the solid model allows the automatic production of the realistic images of a shape and geometric input for finite element analysis or even manufacturing tasks such as generation of instruction for numerical control manufacturing. म्हणजे आता कसं आहे वायरफ्रेम मॉडेलमध्ये आणि सरफेस मॉडेलमध्ये आपल्याला त्या पार्टची पूर्ण माहिती मिळत नव्हती, ठीक आहे. बट इन टर्म्स ऑफ द सॉलिड मॉडेल वी आर गोइंग टू create such a model where we can collect all the information regarding that particular model in terms of physical information as that geometrical information for our further. Suppose I want to do some further FEA analysis of the solid model, so it will be easy and it will be allowed to create analysis by using that solid model. So I am going to create analysis in that particular model, solid model, in finite element analysis. So just I will import that 3D part in FEA software, and just I am applying the various conditions, and then I will solve that problem. Okay, that will be easy. But in terms of the wireframe and surfaces, it is creating some errors, or that system will be show error message prompt on the screen, like some information is incomplete about this model, so please complete this task and then go for the further analysis. Okay, so even I want to create that model in actual manufacturing, so I will directly transfer this model information to the NC part programming, or we directly give this model to the manufacturing departments. Okay, so that is the advantages of the solid modeling. Okay, so we will see some advantages of the solid modeling. It has all the advantages of the surface models, that is the uniqueness, non-ambiguous, realistic surface profiles, plus volumetric information. So In the surface solid modeling, we will get uniqueness, we will get a realistic product views. There is no difficulty, no ambiguity, and the surface profile is clear. Then we can calculate the area and volume information from the solid modeling. Okay. Then it allows the designer to create a multiple option for designs. Okay, once you created a solid model, then you can create a multiple design on that part. Okay, then apart from that part, you can create any other entity for the three-dimensional solid model. Okay, so a designer can create the any 3D model. Then two-dimensional standard drawings, assembly drawings, and exploded drawings are generated from a model. Once you generated 3D in terms of the modeling, from that model, suppose to create drawing, to create means I want to create DW, then that will be easy for okay. You created a part modeling, then I can easily draw the two-dimensional part drawing, then assembly drawing. Exploded views means that 3D components I want to view front view, side view, top view, left side RHS. Like this isometric auxiliary n number of views you can just explore in that drawing and automatically generated all the views okay in this model. That is the most important advantages of this solid modeling. Okay. Next, it can easily be exported to different finite element method programs for analysis. Once you completed this 3D model design in any CAD and CATIA software, then design engineer wants to check whether it is sustainable in this given condition or not. So for that purpose, we can import this model into FEA software easily, and then design or analysis engineer easily check whether that part is running is smoothly sustainable for given conditions, boundary conditions, and loading conditions. If yes, then that part is the passes to directly manufacturing department. If not, they will again send back to the design engineer. They have to changes whatever requirement as per requirement, and then the design changes engineer will again send to that part to the analysis engineer or analysis software. Okay, so like this we are using this solid modeling for our further processor. So that is the most important advantages of the solid modeling. Next, it can be used in a newly manufacturing techniques. Okay, computer integrated manufacturing, computer aided manufacturing, and design for the manufacturability. Okay, so whatever new techniques are coming for the manufacturing purpose, so we can easily use this solid model part for our new techniques. You can import directly that part to the CAM system or CAM system, computer integrated manufacturing. Whether here we are going to integrate all the department at a single point, means CAD department, CAM department, and CA department, and we are going to doing a production of that particular part by using this different department at a single point. That is called as a concurrent engineering. So you might be studying in first year in mechanics. What is mean by concurrent engineering? All forces at coming at a single point. Like this, we are going to create a model, create a particular part with using the SIM manufacturing technology. That is the computer integrated manufacturing. Here we are going to entering or allow to all department at a single point only. Okay, that will be save our time as well as increase our productivity. Okay, so SIM is an important department for a particular model. So next part is volumetric and mass properties of an object can be easily obtained. Okay, So whatever we have seen drawbacks in wireframe and surface modeling. So in that solid modeling, we can easily download or easily obtain the information about the mass, area, volume, and corresponding the mass properties as if density is included. Okay, so whatever that remaining physical properties and regarding that the geometrical properties, we can easily obtain in terms of the solid modeling. So these are the some advantages. So we will see some disadvantages of the solid modeling. What are the disadvantages? Okay. First is a more intensive computation than the wireframe and solid modeling. Obvious, of course, in solid modeling, there are the lot of data of that particular model, so that will take a more time for the computational at the time of the analysis as compared to the surface and wireframe model. Okay, in wireframe there are only edges and lines, okay, curves. In surface modeling only surface is there, but in solid modeling there is a lines, vertices, surfaces, then solid part, then physical property of that particular model. So that will be take a huge time for the computational. Okay, so that is the most disadvantages of the any solid modeling analysis. Okay, but it will be give a better accuracy as compared to the wireframe and solid surface model. Okay. Second thing is it requires more powerful computers faster with more memory for use of the analysis. Okay, so बऱ्याच ठिकाणी कंपनीमध्ये असे स्पेसिफिक अनालिसिसच्या कंपनी असतात. त्या ठिकाणी जे आपण नॉर्मली आपले कम्प्युटर कॉलेजचे पर्सनल PC लॅपटॉप जे बघतो ते कसं फक्त नॉर्मली पर्सनल यूजसाठी जे काही त्यांचं कस्टमायझेशन केलेलं असतं, म्हणजे ठराविक मेमरी 4 GB memory, suppose 1 TB hard disk, 2 GB graphics card. Like this, we are going to customize our personal laptop. Okay, but in this company, they are customize their laptops, their computers as per the requirements of the analysis and design of that particular product. So they are making a more powerful computer, which more memories and which is a more graphics cards. So that will be allows to do the analysis in higher level. So that are the some disadvantages of the solid model analysis. So for that solid model analysis, they require a more powerful computer. Okay, so that will leads to the high cost and high investment of the company. Okay. Look, so next point is just a differentiation about this three modeling like wireframe, surface, and solid. Okay, so whatever we have studied up till now, what is mean by modeling, geometric modeling, in that there are three types: wireframe, surface, solid. What is the use of the wireframe? What is the use of the surface and solid modeling? What are the advantages, disadvantages of the wireframe, surface, and solid? So at a single this slide, we will just analyze, we will just conclude the part of this three modeling. Okay, so I'll just ensure. Hello, Aniket. Yeah, sir.
हाँ सर.
सगळं ऐकू येतं ना, व्यवस्थित दिसतंय ना?
हाँ येते सर.
Okay, okay, ठीक आहे. So we will see just the difference between these three type of the modeling with the help of this parameters. So first parameter is computer memory space required. Okay, already we have seen that in a wireframe model there is only vertices and edges, so it will be required the less computer memory. As compared to surface, it will require a medium level, moderate, and in solid model it requires a large memory. Okay, so first parameter as per the computer memory space required. So we will see next part, that is the entity used. In the wireframe model, what are the entities we are going using, like point, line, circle, ellipse, synthetic curves such as the Bezier, Hermantide, B-spline. So that are the entities for the drawing wireframe model. We are using this type of the entities. In surface model, we have seen already the types of the surfaces: plane, ruled, revolved, tabulated, free from the surfaces, and synthetic curves like the B-spline, Bezier. Okay, and solid model. So directly we are going to using primitives, and that is the one thing. Then you can use the wedge, spear, cubes. Okay, and then you can use the various tools like you can use here a line also, point also, and from that line point you can create any a solid part. That is also possible, but that will be take the large time. Okay. Third parameter, that is the input data required. So for a wireframe, we require a large data, lot of data for creating the wireframe, any vertices, every edges information. So as compared to surface and solid model, we require a huge input data in wireframe model, moderate in surface, and solid for less. Automatic orthographic perspective isometric view generation. That is the next parameter in wireframe. That is impossible to create these views. In surface model also it is impossible, but in solid model you can easily create by using this views command. You can create any views. Okay. Then next there is NC code generation. So for a wireframe it is not possible, and in solid model it automatic possible, surface model also automatic possible. NC code generation means for manufacturing, at that time manufacturing we have to give in terms of the code, G code, M code, that is the NC code we can call as for the manufacturing. Once you import that code into the NC machine, that machine will be created at the particular model within the less time and with greater accuracy. Okay, so it will be possible for the surface and solid model. Rendering and shadow effect. The next parameter is rendering and shadow effect. So in that wireframe, it is not possible. Rendering is one of the tools for the improving the surface finishing. Okay, so in wireframe there is no surfaces. Obvious, there is no effect of the rendering and shadow. In surface model there is possible, and for the solid also it is possible to create the rendering and shadow effect. Next parameter is cross sectioning. So suppose I want to interested in any section part, so I want to create section. So in wireframe model it is not possible. In surface also not possible, but in 3D parts I will take a full section, half section, partial section. Like this we'll create the different section as per your requirement, as per the design engineer requirement. Okay. So next point, that is the CAD/CAM CAE models. So what are the models for the wireframe? Only drafting. We can create the drafting only in the wireframe modeling. But in surface modeling, you can create the drafting as well as the design. Okay, because there is a surfaces. And last one, solid model, there is a drafting, design, manufacturing, analysis, assembly, mechanism. We can create design, drafting, analysis by using the CA tools. Okay, in the solid model. Next, calculation of the physical properties such as volume, mass, and mass of inertia. So in wireframe, not possible. In surface, possible to calculate the some properties, not all properties. Okay, and in solid model, it is possible to create the all properties. Next point is elimination of the hidden lines. So in wireframe model, elimination of the hidden line is automatically, manually. If you want to hide some lines, then you can just click on that line and just hide up that particular line. That is possible in wireframe. But in surfaces, it is maybe possible at a single point. Not every time we can just hide that all the surfaces or lines. But in solid model, we can hide just all the points, lines of that particular model with using the tools. We can visualize the all edges, vertices by using this view command. Okay, in 3D. The next part is the design parameters optimization. So whatever that optimization technique is there, there is not applicable for the wireframe model because there is no surfaces and then no solid part. Okay, for surfaces may be possible for certain surfaces, and for solid part it is possible. Next and last point, that is a interference between mating parts. Okay, means assembly. So in wireframe it is not possible. If in surfaces, I want to join two surfaces, then it will be possible. And in solid, I want to just join different two parts, so it will be possible. So this is about the just overview about the three types of the modeling. One of the first wireframe modeling, second surface modeling, and last solid modeling. So up till now, today's lecture we have seen that what is the meaning of the geometric modeling, what are the uses of this geometric modeling, then what are the types, first wireframe, what is the use, what are the application, what are the advantages, disadvantages of the wireframe. Same thing for surface and solid model. So just I request to all students, just keep in mind these parameters, 12 parameters, and you can just memorize these three types of the modeling types. It will be easy for you to understand and remember these three modeling types. Okay, so this is about the modeling and their types. So we'll move towards the next point. So for a representation of the any solid model, there are some schemes. So first is that the CSG, that is a constructive solid geometry, that is the solid primitives combined with the Boolean operations. Means we are going to combine the cone, sphere, okay, with the Boolean operations, means addition, subtraction, okay, like this. This is the first type of the representation. Second, boundary representation, that is the B-rep, that means bounding faces, edges and vertices. And third, that is cell decomposition, means we are going to adding the some part of the component model with the other part, that is a variable spatial cells. In that there are two types, spatial occupancy enumeration, that means model of the fixed size, and next octaric encoding. And fourth one is sweeping, like this, translation, rotation, and arbitrary sweep. You can sweep in the terms of the in global coordinates. And last one is that is the pure primitive instancing parametric model. So there are some schemes for representing the solid model. So we are not going to see all of this. We are going to just see 2 or 3 parts. So we'll start from the first, that is the constructive solid geometry scheme. Okay. Now you can see there are some example of the basic primitives for the solid modeling. Now we can observe in primitives or entities, there are some model is there ready-made, like box, cylinder, cone, wedge, sphere, and torus. Just you have to just select this any entities, required entities, and you have to just place on the plane. Okay, so that will be create the geometry according to your dimensions. Okay, so this is the first type, that is a constructive solid geometry. Next, for that constructive solid geometry, there are some Boolean operation is there. So first Boolean operation is union. Union means we are going to adding the surfaces to each other. Okay, so this is the union operation. In that we are going to sum up the all points in each of the two defined sets. That is a logical operation, or also referred to as add, combine, join, and merge. You can call it as a union, add, combine command, join command, merge. Already you might be knowing in CAD, there is a union option is there and join is there. Okay, so cut also is there. So there is a two entity. You can see the one square box is there and select A and B, and there is a union operation, A union B. So we will get our required geometry by using this Boolean operation. So this is the first union. The second, that is a difference, means subtraction and remove and cut. You can call that the difference, subtraction, remove and cut. So the points in a source set minus the points common to a second set. There is a logical operation is not. Okay, so there is a two primitives A and B. In that common region is there, and apart from that common region, whatever that region is there, B entities, we are going to subtract that entities, and we will get the new entities from this difference, subtraction, remove and cut Boolean operations. Okay, so this is the second operation. And third operation is intersection, means common and conjoint. Okay, so whatever the logical command for this, and whatever the combined part of these two entities, that is our solution of this Boolean operation. So those points common to each of the two defined sets. Set must share common value. काहीतरी कॉमन पार्ट दोघांमध्ये शेअर झाला पाहिजे तरच ही कमांड ऍप्लिकेबल आहे. And it is also referred as a common conjoint Boolean operations. You can call it as a common and intersection. Okay, so this is about the constructive solid geometry and the Boolean operations. So next part, that is a Boolean operation. Using Boolean operation, be careful to avoid situations that do not result a valid solution. असं काहीतरी ऑपरेशन तुम्ही बुलियन ऑपरेशन यूज करताय आणि त्याच्यातून तुम्हाला काहीतरी वेगळं सोल्युशन येतंय जे की ते व्हॅलिड नसतं. ठीक आहे, अशा वेळेस थोडी केअर घ्यायची. ठीक आहे, आता इथे बघा ए आणि बी दोन असे एंटिटीज आहेत आणि त्याच्यामध्ये दोन सरफेस एकमेकाला फक्त अटॅच केलेत. म्हणजे आता तुम्हाला ऍक्च्युली काय करायचं तेच कळत नाही. म्हणजे कमांड कोणती यूज करायची, इथं तुम्ही काय यूज केली आणि तुम्हाला काय भेटलंय आणि तो रिझल्ट व्हॅलिड आहे का. ठीक आहे, कोणत्या वेळेस कोणती कंडिशन यूज करायची, कोणती बुलियन ऑपरेशन यूज करायची जेणेकरून तुम्हाला काहीतरी व्हॅलिड रिझल्ट मिळेल, रिझल्ट मिळेल. ठीक आहे, आता इथं फक्त सरफेस मिळाला आणि तो 3D मध्ये आला आहे का, त्याच्यावरती काही तुम्ही पुढे करू शकता का, अनालिसिस करू शकता, मॅनिफेस्टेशन करू शकता का, नाही. सो दॅट विल बी क्रिएट द ambiguity फॉर द फर्दर प्रोसेस. सो यू शुड टेक केअर अबाउट द operating the various Boolean operation. Okay, so this is the one of the note. Then next, this is the Boolean operation results. First of all is a union. If you want to add any other entity to the different entity, then subtraction, then intersection. Okay, so this is the example of the three type of the Boolean operation: union, subtraction, and intersection. Okay. Now you can just see the one of the example of the simple model, primitive models. Okay, so there is one plate is there. Just then you went to the horizontal plate and you just want to the minus or subtract that circular part. So there are two commands, that is union and subtraction, and from these two commands you will get a final product. Okay, so these are the some Boolean operations here we are going to using at the time of the making the a model. Okay, now you can see observe there are so many parts here we are combining, joining, union, whatever that Boolean operation is there, we are using the different Boolean operations and we are forming a required part. Okay, so like this we have to do a different operations and then we will get the required part. Then you can see here, this is one of the second example. Here different part is there, and from the different part we are going to create a geometry. Okay, so more than one procedure and hence the database can be used to arrive the same geometry. Okay, म्हणजे असे काहीतरी भरपूर ऑप्शन असतात की असं आपण म्हणतो ना की बाबा एखाद्या प्रॉब्लेमला n नंबर ऑफ द सोल्युशन असतात, n नंबर ऑफ द मेथड असतात तो सॉल्व्ह करायला. ठीक आहे, तसंच इथं बुलियन ऑपरेशन मध्ये तुम्ही हेच ऑपरेशन यूज केलं पाहिजे असं नाहीये. एकाच सेम ज्योमेट्रीला तुम्ही वेगवेगळ्या प्रकारे ऑपरेशन यूज करून तुम्ही ती ज्योमेट्री बनवू शकता. ठीक, तर त्याचं सेम एक्झाम्पल इथं आहे. So what are the basic advantages of this CSG, that is constructive solid geometry, in Boolean operations? So for that Boolean operations are intuitive to user, are easy to use and understand, provide for the rapid manipulation for the large amounts of the data. So basically Boolean operation gives you user friendly and greater understandable and it will be provide the greater modification or rapid manipulation. You can change the at a time. If you want to change some geometry of that particular parts, then you can just immediately apply the different operations, and you can modify that the design of the parts. So that are the some benefits from the Boolean operations. Because of these, many non-constructive geometry systems also use Boolean operations. So those who are not in constructing solid geometry parts, system parts, so they are also using this Boolean system for this betterment purpose. So these are the advantages of the Boolean operation, where we can use the user-friendly different operations, and that is understandable, and that will be give a more productivity and saves time also. Okay, so these are the some advantages. CSG is a powerful with a high level command. It is a powerful tool. Easy to construct a solid model in minimum step by using the Boolean operations. CSG modeling techniques lead to a concise database, less storage. It requires less storage for the Boolean operations. Complete history of model is retained and can be altered at any point. This is the very important advantages of this CSG. At a single point, at any point, you can retain, or you can just you can call it the undo of the work, whatever that the information regarding that particular model is easily, and you can just change, modify at any time. Okay, there is no any restriction to the modify or out of the history of that particular model. Okay, so that is the important benefit of this CSG. Can be converted to the corresponding boundary representation. You can convert that model information to the boundary representation at any time with less time. Okay, so this is also a benefit of this CSG. So there are some disadvantages of the CSG. So only Boolean operations are allowed in modeling processes. With the Boolean operation alone, the range of shapes to be modeled is severely restricted, not possible to construct unusual shapes. Okay, so previously we have seen that there are some primitive shapes like sphere, cone, circle, like this. There are cylinder, like this. Only some few primitives there. Rather than this, if you want to create any shapes, okay, so that is quite difficult or not possible to construct the shapes. Okay, so that is the most disadvantages. So it requires a great deal of the computation to derive the information of the boundary, faces, and edges, which is important for the interactive display and manipulation of the solid. In the solid geometry or solid modeling, if you want to create a geometry by using constructive solid geometry, so there are requires a great computation to achieve the information at the location of the boundary, faces of that model, and edges. Okay, now that is a quite difficult part in this CSG. So it is important for the interaction between user and the display at the time of the designing the model, at the time of the analyzing that model. So user should be able to that each and every details of that model in the terms of the edges, faces, and boundary information. So that will be require the further analysis. So that is the disadvantages of this CSG. Okay, so these are the disadvantages. Now you can see the second type of this scheme, boundary representation of the geometry. Okay, so now you can see here one of the example user which is having the 6 boundaries, means surfaces, like named as 1, 2, 3, 4, 5, 6. Okay, simple. We are giving as a number only that surfaces. Okay, like this boundary representation. This is the boundary 1, this is the boundary 2, 3, 4, 5, 6, like this. Okay, this is the useful at the time of the assembly as well as the assembly purpose. So we should know the which surface is named as one, where we can go for the addition or Boolean operation at which surfaces. So that will be a better understandable at the time of the different process. So that for that purpose we are going to give the name for that boundary representation. Okay. So what are the advantages of the boundary representation? So in this boundary representation, its capability to construct unusual shapes that would not be possible with the available CSG, like example aeroplane fuelages, swing shapes. So basically, we have seen some disadvantages in CSG. We are not covered that part, unusual shapes, but that part we are going to cover in boundary representation. Complex geometry we can easily model in boundary representation. In terms of some curve is there, curvature part is there for the aeroplane, some blade is there which is having some curvature. So that part we are going to model in the boundary representations, and it will require less computational time to reconstruct the image. Once you have a construct image, and in that construct image if you want to change something, so it will be required the less time in the boundary representation. Just only you have to change that boundary name, means we have to just focus on the whatever the changes at particular boundary. Okay. So what are the disadvantages of the boundary representation? So it requires more storage because we are going to involve each and every point and vertices and edges of this boundary. Then more prone to validity failure than the CSG. It is given, it is not valid for the any failure at that modeling as compared to CSG. Then model display limited to the planar faces and linear edges. Whatever that planar and linear edges that will be only displayed, there is also limitation. And complex curve and surface only approximated. Whatever they are going to drawing or model that complex and surface curve surfaces, that is approximated, not accurate. Okay, so that is the disadvantages of this boundary representation. Okay, so we have seen the difference between 3 modeling, wireframe, surface, then solid. Then we have started the solid modeling schemes in that first CSG, that is a Boolean operation. Then we have seen the boundary representation. Okay, so in this scheme, just we have to focus on the how to draw the any solid model with the less time and with the accurate part. Okay, and there are some advantages of the scheme and some disadvantages of the scheme. Okay, so next is just cell decomposition. This is only for the information. Okay, just how we are going to decompose a cell of the particular model. In that first you can see here there is one solid model. In the second image you can see the model with the 3 cells. We are going to divide that model into the 3 parts. Okay, 3 cells, and last one is the model with the 7 cells. Like this we are going to just divide it, means decompose this that the particular model into n number of the cells, and that cells particularly you can just see there is named like 1 2 3 4 5 6 7, and for at the time of the assembly of particular process analysis we are just going to select the particular cell only. Okay, if I want to interested only on cell number 3, then I will go only for the number 3. Why I am focusing about the remaining part of the cells. Okay, like this we are going to save our time. You can improve our productivity, and then automatically it tends to the greater productivity. Okay, like this we are going to using this scheme for the solid modeling. Next, now you can see a spatial occupancy enumeration. Like this we are going to just divide that particular model into the n number of, like we have to do the meshing. Okay, and that will be provided for the process. This is only your information. This type of the scheme is not asking in exam. This is for your information purpose. how we are going to using the different types of the solid geometry scheme. Just I want to know to you. This is next octree encoding. There are some difference between structuring about that machine. They are going to create the only lines. They are not going to create the small elements and octree encoding. This is the third type of the solid geometry scheme. Then this is already we have known that the sweeping. Suppose I want to create in solid geometry by using the various sweeping command. Just you have to draw one of the axis. So drawing along that axis, you are going to just create the solid part. Okay, by using this sweeping command. Okay, so this is the very easy for the drawing any solid part. So this is the easy solid scheme. Then next, the pure primitive instancing. So these are the one of the job like this in workshop you have done in last semester, I think, in metal parts. So there are n number of operations, grooving, facing, milling, whatever that operation is there. So like this pure primitive instancing, whatever the dimension is there, allowance is there, whatever the surface finishing is there, whatever all such things comes under to this surface modeling. Whatever. And that type of the modeling is done in MC machining, that CNC, VMC. Okay, like this, we have to create the solid model. Next is applications of the solid modeling. Okay, so what are the application here we can use this solid modeling? So first is graphics, design, manufacturing, and assembly. Okay, so in the time of at the time of the assembly manufacture, there are requirement of the functional part. So at that time, solid modeling is applicable. Like this, there are different sectors there. Here we can use the solid modeling. In design section is there, graphics section is there. Like this, there are a number of the parameters where we can use the solid modeling. So today we have seen so many theory parts. So today we will stop here. Just I will memorize what we have studied in today's lecture, and we will stop here. Okay. Hello, अनिकेत.
हाँ सर.
हा, आवाज येतो ना?
हाँ येतोय सर.
ओके, तर आपण आज सेकंड चॅप्टरचा सेकंड पार्ट बघितला. त्याच्यामध्ये वी हॅव सीन द व्हॉट इज मीन बाय द जिओमेट्रिक मॉडेलिंग. In that there are three types: wireframe modeling, solid modeling, and surface modeling, and their advantages and disadvantages. Then we have seen the difference between three modeling with the terms of the some parameters. Then we have seen the different solid geometry schemes, in that CSG, boundary, cell decomposition, like this spatial, and last is application of the solid modeling. So basically you might be know the what is the use of the engineering drawing and engineering CAD systems. So for betterment of our and visualization of our products or models, we are going to use different types of the modeling, and side by side we are going to use different CAD tools for creating the different models. Okay, so remaining part of this chapter and part of the geometric modeling, like the parametric representation and the different types of the curves, that things will be covered in the next lecture. So if anyone is having any doubt regarding this today's session, if any part is not understandable, so then you can raise a question in chat box or directly I will answer. Okay, so we will take a 5 to 10 minutes discussion forum or question answering forum. You can just raise your hand, or you can just put your queries in your chat box, then I will answer of that same. Okay, start. If anyone is having any query, just raise your hand. Rhythm Parmar. शितोळे, खोटे, माळी, उबाळे, हॅलो, सगळेजण ऐकताय ना?
येस सर.
हा सर ऐकतोय.
हा, काय प्रॉब्लेम आहे का? काय कळालं नाही?
नाही सर, काय नाही.
ओके, ठीक आहे. तर आय रिक्वेस्ट टू या सर, प्लीज स्टॉप द रेकॉर्डिंग.